and this is our forensics assignment. For this forensics assignment, we were tasked to create a tool that incorporates both forensics and AI. So our tool is called Forensics Vision. This tool is a basic architecture based on three major parts: object detection, tamper detection, and then integrity insurance. These three parts can all be activated separately in our application. The two AI parts, object detection and tamper detection, are as follows. So the DOI, object detection, uses a ResNet architecture with the SCID connections, and the Mantranet uses a normal VGG architecture. As you will expect, object detection uses a normal implementation of computer vision, takes as input a list of words that you are looking for in an image or a group of images, takes in the group of images as input, and then returns what objects are identified in that image based on the words. If we look at Mantranet, that does tampering detection. It is split into two parts, namely detection and localization. Localization is just segmenting the tampered regions of the image. It is an end-to-end system that takes in an input image and that outputs a pixel-level forgery likelihood map. We will show this later in the demo. It is important to note that these architectures have been pre-trained, so we use pre-trained data, and they can be improved with further training. But without further ado, onto our demo. The pre-processing that we do is based on converting images in our image directory to JPEG. So let's just define our case, and then here we see it asks us to input path to a folder to the images to analyze. So in this case, we insert images. Now this is this directory, and pre-processing will convert all of these images to JPEG and also remove any images any files that are not images. Here we are asked, we want to perform object detection, but we also want to perform tampering analysis. Here we can now insert a list of words that we want to look for in the images, and since this is a forensics investigation, we will look for knives and scissors because they are sharp and can possibly be included in a crime. So what is executing now is our first object detection, and that model is defined under DOI, where we just give it the image and give it the list of names, and it goes and identifies the images. So as you can see, it identified a knife, and it also identified a scissor. It identified 4 images in total. Now it asks us, do we want to perform tamper analysis? And it asks us, do we want to perform it on all the images in the image directory or the identified images? Here we pick the identified images. This uses the Mantranet model, and that is in this file. And as you can see, it did the detection on the files, and here we can see the results of that. The highlighted regions, or the regions that you can see that's not black, was flagged as being tampered with. And obviously, because we drew the bounding boxes onto the images, this is indeed the case. It is important to note that the Mantranet and DOI are the models that we use from outside. And now we can also store our results for integrity checks later on, but Nipo will tell us more about that.
Yes, so what we did is we used image hash library to calculate the hash values, and we also used the Python imaging library to open and perform operations on images. And basically, what this implements is it implements a simple database to store previously calculated hash values for comparison and for comparison purposes.
Okay,
Yeah,
thank you for our demo. And yeah, okay, that is perfect.
hopefully that's shorter.